one last topic to cover. And then, because it's a nice day, if I get through this, I feel I've covered it sufficiently, I'll stop a little early. I know how sad that makes some of you. Those of you who applauded, thank you. All right. So we really only have one more thing to do. This will be on the final. And it's anti-derivatives. That doesn't mean people who hate derivatives. It means going backwards. Okay? And some of you were leaving early. That's how long my first marriage lasted. Just kidding. That was the seventh marriage lasted. All right. Anti-derivatives. Anti-derivatives is going backwards. So in other words, we give you the derivative, what's the original function? So if I told you, for example, if the derivative of something is x squared, what's the original function? Well, it would be, the original function would be x cubed over 3, or 1/3 x cubed. Why would it be that? Well, take the derivative of this, and you get that. So this is the antiderivative. Okay? It's working backwards. How do I know that? Well, I'll get to that in a second. Here's one of the problems, though. What's the derivative of x cubed over 3 plus 1? It's x squared. What about x cubed over 3 plus 2? It's x squared. So, the problem that you get when you're going backwards is, because the derivative of a constant is 0, there's an infinite number of possibilities for what the original function was. Okay? So what we do is we write x cubed plus c, where c stands for a constant. We don't know what that constant is, so we just write plus c. Now, if we give you more information, you can often figure out what c is. So suppose I told you that f of x equals x squared and, I'm sorry, that f prime of x equals x squared, and f at 0 equals 4. And now we say, go backwards and figure it out. You say, well, I know the original function must have been x cubed over 3 plus a constant. And I know that when x is 0, y is 4. So 4 is 0 cubed over 3 plus the constant. The constant must be 4. So now I can say then the real function is x cubed over 3 plus 4. Okay? So sometimes I can find the actual function. Sometimes I can only find the general function. So this is called an indefinite. Okay? And this is definite. Well, not quite, but for now. Okay? So sometimes you can find the actual value, sometimes you can't. And how will you know which one? Well, we'll give you the second piece of information. Alright, so now let's just take any f of x, any f prime of x, and say it's x to the n. So if the derivative of a function is x to the n, what was the original function? Well, it's x to the n plus 1 over n plus 1 plus some constant. Take that in your head. Bring the n plus 1 down. It's going to cancel with that. Subtract 1 and you're going to get x to the n. Okay? So notice when we take a derivative, normally when we take a derivative, what do? You bring the power down, so you multiply, and you subtract 1 from the power. So now here we're going backwards. So you add 1 to the power and you divide. Okay? So you're doing the reverse functions, the inverses. Okay? And that's how you know you're doing inverse, you're doing derivative and antiderivative. So I tell you, so if you know that the antiderivative of, if you know that the derivative of a function is x to the 4th plus x to the 3rd plus x squared, what's the original function? Well, And you're going backwards. You say, well, it's x to the 5th over 5, plus x to the 4th over 4, plus x to the 3rd over 3, plus a constant. We got that. ¿Es fácil? Es muy fácil. Sí. So that's not very hard, but of course we're going to make this harder. But let's store that over here on our list of antiderivatives. So one of the ways we write antiderivative is we write the derivative as a lowercase f, and the antiderivative as the uppercase. You guys ready for the Rock Armageddon on Friday? It's going to be fun. Some of you are going to get wet. Some of you are going to get wet. Okay? You know who you are. You get that green stuff all over this. Alright? So that was an easy thing. So let's do some more antiderivative stuff. Let's see. What's the derivative of 3x? If you had f of x equals 3x, then the derivative is 3. In fact, if f of x is a constant times x, then the derivative is just a constant. So now let's go the other way. If I know that a function is equal to a constant, then the antiderivative is kx plus c. You always have to write this plus c because it says I don't actually know what the original function is. All I know is if I take the derivative of this, I'll get back to here, but the constant could be anything because the derivative of a constant is always 0. A constant's a number like 2 or a half, or pi to the 10th. Okay, or log of 7. Those are all constants. Okay. All right, now let's do some other fun ones. F of x equals e to the x. What's the antiderivative? Almost. Plus c. The TH will take off if they don't see the plus c. Okay? So far so good? What's the derivative of the log of x? F of x equals ln of x, inverse, and the antiderivative is 1 over x plus c. So let's add that to our list. I wrote that backwards. Hang on. Okay? Basically, the derivative of this is this. So the antiderivative of this is that. Okay? That's really all you're doing. You're just going backwards. All right? What else do we have to learn the antiderivative of? Oh, some trig functions. You never escape the trigonometry of those. Never. You're going to be there studying for your MCATs. They're going to ask you trig. You're going to be in med school. And you're going to say, what do I do? And they're going to say, oh, patient, we need the vital signs. Just had to get that one in there. I went off on a tangent there. You know, I can keep going. All right. If you have a function, what's the derivative of a sine? Cosine. So the antiderivative of sine is negative cosine. Because, take the derivative of this. You get that. Okay? So the antiderivative of sine, we'll make another column here. Okay? You ready? Gotta go try some? Okay? Find the antiderivative. If you start with that function, what's the antiderivative? I'll give you a clue. You might want to multiply that out first. I'm just copying the problem from the book, folks. Don't blame me. I didn't write this book. I'd be wealthy if I wrote this book. The guy who wrote this book is probably a millionaire many times over. You get a lot of money.
Why would you quit that?
Let's see at the end. And the whole thing plus C. That you know specifically. X, then you must start with x squared over 2. If you have 3x, then you have 3x squared. X squared over 2. Write it down, take the derivative. That's long enough. Long enough? Alright. So what would we do if we wanted to find the antiderivative of this? Well, first, I would multiply it out. You can get 2x squared plus x minus 1. And now to get the antiderivative, 2x cubed over 3 plus x squared over 2 minus x plus a constant. So if you're not sure, take the derivative, go backwards. How do I know that the antiderivative of 1 is x? Because the derivative of x is 1. 1 is a constant, right? So if you have 1 as a constant, the antiderivative is a constant times x. So if you have 1, the antiderivative is 1x. Okay? Let's do another one. Make sure you guys can do this, because this is going to be on the final. Suppose you have 5x to the 1/4 minus 7x to the 3/4.
Go back.
All right, let's do this one. So this is the annoying part, is you have to add 1 to a fourth and 1 to 3/4. So we have 5x to the 1/4. 1/4 plus 1 is 5/4. Divided by 5/4. Minus 7, x to the 7/4. Divided by 7/4 plus c. Now, of course, you should be able to simplify that. You flip the fraction. You flip the fractions and multiply, and you get 4x to the 5/4 minus 4x to the 7/4 plus c. But this is perfectly fine. Okay? You would want to turn it into this if you needed to do something else. Okay? What if you had what if you had f equals 3e to the x plus 7 secant squared x? Well, derivative of what is secant squared? Tangent. So look at that. So if we wanted to do the antiderivative of this, it's 3e to the x plus 7 tan x plus c. When you're not sure, take the derivative in the other direction. Okay, let's try something slightly different. Okay, now let's suppose I tell you that the derivative is 5x to the 4th minus 2x to the 5th, and that the original function at the value 0 equals 4. That can help you figure out what c is. good half. Okay. You figure this one out? See? Got it. All right. So we do the antiderivative. You get 5x to the 5th over 5 minus 2x to the 6th over 6 plus c. And I know that f at 0 equals 4. So 4 is, you can cross out those 5s, is 0 minus 0 plus c. So c equals 4. Therefore, the antiderivative is x to the 5th minus 2x to the 6th over 6, which you certainly could deduce, plus 4. So this information helps us find the exact function. Suppose I had Alright, so antiderivative. Capital F of x is 3x plus 5x squared over 2 minus 2x cubed over 3 plus a constant. That's beautiful, 3. Okay? Now we know that f of 1 is 2. So 2 equals 3 times 1 plus 5 times 1 over 2. Well, that's a fairly sadistic pair of fractions, but I think we can do that. So you get 2 equals 3 plus 11/6 plus c. So you get negative 17/6. Is that right? I'm hanging in there for one more day, folks. You know how I do that? I'm old. I didn't have a calculator growing up. We just discovered fire. You don't think we had electricity back then, do you? Okay? So that's your original function. Here's something else we could ask you. Suppose the second derivative of x is 6x plus 12x squared. Find the original function. You knew this was too easy. All right, well, the first derivative would be 6x squared over 2 plus 12x cubed over 3 plus a constant, which we can simplify to 3x squared plus 4x cubed plus some c. So that's the first derivative. So now we just have to do it a second time. So that means the original function is 3x cubed over 3 plus 4x to the 4th over 4 plus some constant times x plus another constant, we'll call that c1. So you'd probably have to solve information twice to get to the constants. We have to give you information about the derivative and about the first function. And of course you can simplify that. Where would that show up? Oh, physics. Just pick a topic at random. Suppose we had this. Why do I have the c and the c1? They're not the same constant. Okay? So when you do that, you have two different constants. So you have constant c and you have constant c1. You could call them a and b. You could call them velocity and displacement. You could velocity, something like that. So the second derivative is 2 plus x squared. And I know that the first derivative is equal to 4 at 0. And the original function, sorry, that should be now, is equal to 10 at 0. Now I can solve this. You say, well, the first derivative must have been 2x plus x squared over 2 plus x cubed over 3 plus c. And I know when x is 0, this was equal to 4. So 4 equals 0 plus 0 plus 0 plus c. So the original derivative, the first derivative, is 2x plus x squared over 2 plus x cubed over 3 plus 4. And now I have to find the original function. So that's going to be 2x squared over 2 plus x cubed over 3 times 2, which is 6, plus x to the 4th over 3 times 4, which is 12, plus 4x, plus c, or I'll call it c1, but you can call it c again. Just don't confuse yourself. And I know that this time, when I plug in 0, I get 10. So 10 equals 0 plus 0 plus 0 plus 0 plus c. So c equals 10. Or c1. So my original function must have been x squared plus x cubed over 6 plus x to the 4th over 12 plus 4x plus 10. And if you get a problem like this, check. It's very easy to do. Take the derivative again. How do I get that 6? I have x squared over 2. I raise the power to get x cubed, except I have x squared over 2. I get x cubed over 2 times 3, because this is x cubed over 3. Okay? So the 2 times 3 becomes a 6. Okay? Alright, we got a couple others to try. We got one more thing to learn. What's the first derivative going to be? Well, the antiderivative of sine is minus cosine. So here's something that people will mess up on the final. Okay? The derivative of sine is positive cosine. The antiderivative of sine is negative cosine. So you have to remember whether you're doing the derivative or the antiderivative, you're going to get the minus sign wrong. Okay? Very easy to do. The antiderivative of cosine is sine. just check. The derivative of sine is cosine, so the antiderivative of cosine is sine, plus a constant. And now I know f prime at 0 is 1, so 1 is negative cosine of 0 plus sine of 0 plus c. Sine of 0 is 0, and cosine of 0 is 1. So c equals 2. All right? Now I got to get my original function. Well, f of x is negative sine x minus cosine x plus 2x plus c. Check it. The derivative of sine is cosine, so the derivative of minus sine is minus cosine. The derivative of cosine is minus sine. The derivative of minus cosine is positive sine. Then I had c came out 2, so the derivative of 2x is 2 plus another constant. And f at 0 is 1, so 1 is negative sine 0 minus cosine of 0 plus 0 plus c. Sine of 0 is 0 and cosine of 0 is 1. So you get c is 2 again. So your function is f of x equals minus sine x minus cosine x plus 2x plus 2. Now where does this show up? This shows up in calculus. I'm sorry, in physics, using calculus. Haha. Okay? Something called rectilinear motion, motion along a line. Essentially, it shows up when you're doing velocity and acceleration, position and velocity acceleration. Maybe you've taken physics yet? Some of you, physics in high school. If you know the position of an object, then the derivative of that position gives you its velocity, and the derivative of velocity gives you acceleration. And going backwards, if you know the acceleration, you can find the velocity, and if you know the velocity, you can find the position. So let's write that down someplace clever. So if you take the derivative, usually with respect to time of position, you get velocity. And if you take the derivative of velocity, you get acceleration. For those of you who don't know what this means, velocity is how fast something is moving and what direction it's moving. Okay? It's kind of like speed, but the direction also matters. So you can go 50 miles an hour east, or you can go 50 miles an hour west. Okay? That's velocity. Actually, yes, that's east and that's west. Whatever. Okay? So you have your location. How fast your location is changing with respect to time gives you your velocity. How fast your velocity is changing is your acceleration. That's why when you step on the accelerator, also known as the gas pedal, when you step on the accelerator, you accelerate and you go faster. Okay? So acceleration is the change in velocity. So if we tell you how fast an object is accelerating, you can go backwards and figure out some stuff about its location. For example, oh, they did one just like mine. A particle moves with the acceleration (5 plus 4t minus 2t squared). And we know its initial velocity is 3 meters per second. And its initial position is 10 meters. Okay? Find a formula for its position with respect to time. This looks really scary, but it's just a calculus problem. So how do we do this? This is just what we've been doing. Acceleration is the second derivative. So we're going to do the antiderivative to get velocity, and antiderivative again to get position. So if we know that the acceleration is 5 plus 4t minus 2t squared, and the velocity is the antiderivative of that, which is 5t plus 4t squared over 2 minus 2t cubed over 3 plus a constant. And we know that the velocity at time 0 was 3 meters per second. So 3 equals 0 plus 0 plus 0 plus c. The constant is 3. So the velocity was 5t plus 2t squared minus 2t cubed over 3 plus 3. So I'm going to rewrite that up here. So the velocity, 5t plus 2t squared minus 2t cubed over 3 plus a constant. So now I want to find the position. You use S for position. I don't know why either. S of t is 5t squared over 2 plus 2t cubed over 3 minus 2t to the 4th over 3 times 4 is 12. Oh, I'm sorry, I knew what c was. C was 3. Plus 3t plus a constant. And I know the position 0 was 10. So 10, when you plug in 0, these terms are all 0, so just c equals 10. So your position function is 5t squared over 2 plus 2t cubed over 3 minus t to the 4th over 6 plus 3t plus 10. How do we do? You get that one? Huh. I don't know if we can actually ask about that. But maybe. Okay. If we throw objects, if you throw them up and you drop them, you need to know what the acceleration is automatically. I can't believe we're doing this, but I think we would have to tell you this, but if you have a problem that involves gravity, like if I throw something up or if I drop it, okay, then the acceleration is either negative 9.8 meters per second squared or negative 32 feet per second squared. Okay? So for a sample problem, when you take physics, you do a problem, you do a lab called Atlas machine, you can come up with that number. Kind of a nice experiment. Okay, a ball is thrown upward with a speed of 48 feet per second, 48 feet per meters. Okay, a ball is thrown upward from a cliff with a speed of 48 feet per second. Okay? So you're tossing it up. And the cliff is 432 feet above the ground. So you've got a cliff, and you toss the ball up. And this is 432 feet. So that means your initial position is 432, and your initial velocity is 48. Okay? What time does it hit the ground? Well, you said I didn't sign up for physics class. I know, but here you go. The acceleration is negative 32. So if we want to find the velocity, you just take the antiderivative. You say, well, the velocity is negative 32t plus a constant. And I know that the initial velocity is 48. So 48 is negative 32 times 0 plus c. So c is 48. Therefore, the initial velocity is negative 32t plus 48. Now we're going to find the initial position. I take the antiderivative of that. That's negative 32 t squared over 2 plus 48t plus a constant. And the initial position is 432. When I plug in 0, I'm going to get 0 and 0, so c is going to come out 432. Everybody starting to see that pattern? Okay. So the position is negative 16t squared plus 48t plus 432. So when does it hit the ground? What's the height when it hits the ground? Sure. How do you know? Well, you throw it in the air. 0. Okay? That was your physics experiment for the day. So we want to know when s is 0. So you said equal to 0. I bet they're all divisible by 16. What do you think? I think they're all divisible by negative 16. You get t squared minus 3t minus 20. I'm sorry? 27. Right. Okay. That factors quite nicely. No, it doesn't. That doesn't factor this one. So you have to do the quadratic formula. Hey, it's the example from the book. What do you want from me? Okay? It can't be 3 minus the square root of 117 over 2. That's a negative number. So the time it hits the ground has to be 3 plus the square root of 117 over 2 seconds. You know, if you're going to take the time to make 432, then you should take the time to make it factorable. I don't think that's that much to ask, right, Mr. Stewart? I would have made it factorable. It's my punishment for reading the problem from the book. Okay, let's try another one of these. We're not going to do too many more of these, I promise. I'm sorry? Really? Oh yeah, I thought the market's testing 5:30. Well, we'll do another problem. Okay. Well, how do you guys work one out? Okay. I told you we'll stop early. I know it's a nice day, and I know you guys have the exam at 5:30. A ball is thrown upward from the roof of a 128-foot tall building with an initial velocity of 32 feet per second. When does it hit the ground? So this is just like the last one. Should we do it as a team, or should I have you guys try it first? Who wants to try it? Wow, one person! Wow, I think we're going to do it as a team then. Sorry. I'll go slowly. I'll go really slowly. Alright, so you got the roof of the building, and you throw the ball, and it goes like that, and that building is 128 feet tall. And we know the acceleration is what? Sorry, what's the acceleration? Feet. Okay, so we start with the acceleration of negative 32. Good. And I know that the initial velocity is also positive 32, and the initial position is 128. So what do I do first? We're doing it as a team. So first, I have to do the antiderivative. What do I get? You said you want to do it by yourself, so what do I do first? Okay, we'll do it as a team with me being in charge. Alright, so the velocity is negative 32t, because the derivative of 32t is 32. So negative 32t is negative 32, plus a constant. That constant is going to turn out to be 32. Okay? Because when I plug in 0, I get 32 is negative 32 times 0 plus c. So c is 32. So the velocity is now negative 32t plus 32. Alrighty. Now let's find the position. So I do this again. I do the antiderivative of 32t, which is negative 32t squared over 2. Gotcha, great. Plus 32t plus a constant. This becomes, with a little simplifying, negative 16t squared plus 32t plus 128. Where did the 128 come from? Because when t is 0, 0 and 0, these go away, and you get 128 equals c. Alright, now I want to find when that is equal to 0. So I take negative 16t squared plus 32t plus 128 equals 0. Divide through by negative 16, which we don't have to, but it makes life easier. You get t squared minus 2t minus 8 equals 0. Does that factor? Minus 8. Does it factor, Diana? Yes, it does. That wasn't so hard, Mr. Stewart. I don't understand what his problem was. So you get t equals 4 seconds. That's when it hits the ground. Or t equals negative 2 seconds. It can't be negative 2. In negative 2 seconds would be going back in time to here. Now, one other thing we could ask you. We could ask you, what's the maximum height? How high does it get? So you would find the maximum height. What happens when you throw something in the air at the top of its height? The velocity is 0. Right? Get up, stop, back down. So we would go to the first derivative and set it equal to 0. Does that make sense? Because the velocity would be 0 at the top of its arc. So the first derivative is going to equal 0 at t equals 1. You should be able to do that one in your head. Okay? And then if you take 1 and you plug it in a position equation, you'll know how high it got. Okay? Again, if you want to know the maximum height, you take the velocity and you find where it's 0. That'll give you the time that it's at the maximum height. Then you take that time and you plug in the position and you get the height. You guys all look very restless. So, we'll stop. I'll see everybody on Monday. Have fun on Friday for the regatta.